Hello, and I want to welcome you to part 2 of our discussion on exponents. For this video, we will discuss power of a partial product rule, power of a quotient rule for exponents, and zero exponents. So let's get started with our talk on power of a product rule. If n is a positive integer and a and b are real numbers, then we have a and b inside parentheses, with n being the exponent. And what does that reduce down to? That reduces to, well, it's kind of like that. You can think of it as a strange way of the distributive property, where we have to place this exponent across everything inside the parentheses. So we're going to have a to the nth power and b to the nth power. If we look at this example down here, we have in parentheses 3x, and that is all being raised to the fifth power. To distribute this out, to look at the expression, we just carry the fifth to the third and to the 3 and then to the x. So right here we have 3 to the fifth times x to the fifth power. If we look at some examples following these same rules, we're going to have this form. We're going to take it across everything inside the parentheses. So s to the fourth power, and then we have t to the fourth power. That's what we have for that. And you can think of it as being multiplied together. So just to give a simplified form, it would just be s to the fourth, t to the fourth. And for part B, think of it as putting this 3 with this 2 as a base, and then a as a base. So we have 2 to the third times a to the third. And from the previous video, we learned that 2 is a base with 3 as an exponent. So we multiply 2 by itself 3 times. And 2 to the third power is equivalent to 8. So we can write 8, replacing the 2 to the third power term, being multiplied by the a to the third term. So we just bring the a third term over.
Are you recording?
Okay, so now let's bring the squared term across everything inside the parentheses. So we'll just say every term inside having the exponent of 2. So -5 squared times this x squared times y to the third squared times z squared, oh, excuse me, that is not a z squared. It's just a z being multiplied to the second power. So now if we go through and simplify, -5 squared is equivalent to 25. We can use the properties that we learned from the previous video and just add these together. Multiply these together. So 2 times 2 would be x to the fourth. Have our y as the base, and just multiply these together. We will have 6, because 3 times 2 is 6. And then, of course, that's a 1 right there. So 1 times 2 is 2. So z squared. And that is your answer. Now let's talk about power of a quotient rule. So we have, if n is a positive integer and a and c are real numbers, then something where c is not equal to 0. So for this, let's have a over c to the nth power. And it's going to be equivalent to a to the nth power over c to the nth power. Just like that. And we do not let c equal 0. Excuse me, let me get that in the shot, because that would make something over 0, which is an undefined answer, which does not exist. Okay, now if we just look at this example, we have y over 7, all that raised to the third, and we just separate it by saying each term inside the parentheses raised to the third power, just as we see. So y over 7 to the third power, all that, just break that down to y to the third over 7 to the third. And let's do some examples. So just as before, let's take the 7 and bring it to everything inside that parentheses, and we're not going to let 7 equal 0. So we have 7 to the, or m to the third over n to the 7th. Excuse me. We have m to the 7th over n to the 7th, where n is not equal to 0. For part B right here, we have the term 2x to the 4th over 3y to the 5th, and all that is going to be raised to the 4th power. So, to break that down, let's start by drawing the fraction bar. Let's take this 4th and bring it to everything inside. So we're going to have 2 raised to the 4th times x to the 4th raised to the 4th. And the same way down here in the bottom, we have 3 raised to the 4th times y to the 5th raised to the 4th. So we simplify that 2 to the 4th is equal to 16. Using our rules that we learned in the previous video, we multiply these together, giving us x to the 16th power. On the bottom, we know that we can use our rules of exponents to say that 3 to the 4th power is equal to 81. And we can multiply these together, these exponents, and let y be our base to the 20th power. Now, let's talk about quotient rule for exponents. We're going to build on the rule we just learned. So, if m and n are positive integers and a is a real number, then something when a is not equal to 0. Let's see what we have. A to the power of m divided by a to the power of m. And what does that mean? Well, let's just subtract the exponents. So a is equal to, or it's equal to a to the m minus n power. So if we look at these examples down here, we follow the same pattern. X to the 6th over x squared, we just take the powers and we subtract them, with the numerator's exponent being the first number appearing in the subtraction. So what we did was say 6 from bring it right there, and the 2 on the bottom, make it being subtracted. We're just left with x to the 4th, where x cannot equal 0. Because if we let x equal 0, the denominator would be equal to 0, and as we have talked about before, that would be an undefined answer. So let's look at some examples. Example A, we are just going to have x to the 5th over x squared. Just as we did in the example before, let's subtract the two exponents. So we're going to have x as the base to the raised to the power of 5 minus 2, or we're just left to x to the 3rd power, or x cubed. Alrighty, looking at example B, we have actual numbers in for the base instead of variables. So let's just work this through. So let's bring our base with our exponents subtracting each other. So 7 minus 3, or that's equivalent to 4 to the 4th power. Okay, and finally, if we look at this example below, we have a mixture of real numbers and variables with exponents. So let's break this down. So we have 2 times x to the 5th over x. We're just keeping the variables together, times y squared over y. Okay, so now we know that this x right here has a power of 1, as does that y. When the exponent is not present, we know that they have a power of 1 attached with them. So now we can say, bring that 2 right there, times, let's bring our x's together. So there's a 5 and a 1, so let's say x as the base with the power of 5 minus 1. Now let's work with the y, so let's bring our y, multiplying by y as the base. Okay, and then we look at our exponents, 2 and 1, so we subtract those. So now we just want to simplify. 2, and then we have x raised to the 5 minus 1, or 4th power, and y. We have the power of 2 minus 1, that is just 1. You can write that 1, or you can leave it just as y. Either way does not matter. Okay, and finally, let's talk about zero exponents. Okay, this will be the final discussion point. Okay, so zero exponents. A raised to the 0 power equals 1, as long as A is not 0. For example, 5 as the base raised to the 0 power gives you 1. And that's all you have to know about anything with a zero exponent.